Assalamu alaikum, dear students. I hope you all are fine. We are starting with the A2 physics. I welcome you all in this class. I would like to start with an overview of the syllabus for physics. A2 physics is slightly more challenging as compared to AS. Secondly, the papers that we discuss in A2 are only two papers, paper 4 and paper 5. We are starting our discussion with paper 4 at present. Paper 4 requires you to prepare the entire syllabus. It's a paper which has the largest weightage in our syllabus. In terms of percentage, it is 77% of the syllabus in A2. And paper 5 is therefore 23% of the total A2 syllabus. We'll talk about paper 5 later on, which is more about the planning skills. Paper 4 circular motion is not a very unique and new concept to you. You have studied it in O level as well. Circular motion means an object is moving in a two-dimensional path so that its distance from the center remains the same. In physics, we have several examples of circular motion, and there are so many questions that appear in paper 4. I would like to begin by making a list of several examples, and it's important to understand these examples because we have questions related to these. Simpler is horizontal, and more familiar examples are of those of horizontal circular motion, but there will be examples of vertical circular motion as well. It will come up later on. Number 2,
Yes, sir.
a pendulum bob moving in a horizontal circle. A pendulum bob moving in a horizontal circle. Which means if you suspend a bob from a support like this and you push it away from you or you push it towards you, it starts moving in a circle in this manner. So this is a pendulum bob moving in a horizontal circle. Another example is a car taking a turn. For example, on a racing track, a car takes a turn. That is also studied as circular motion. Even if the car remains in that track for a few moments and does not complete the entire circle, its motion for those few moments will be considered a circular motion. Similarly, a plane taking a turn during its flight is also studied as circular motion. Another example related to which we have a question in the exam, a marble moving in a bowl. For example, if we have a bowl like this and there is a marble initially in contact with one side of it, you push it away from you, it starts moving in the ball in this manner. So this is again a circular motion that we'll study. A simpler example is a coin placed on a rotating disc. So when you place a coin on a rotating disc, the motion of the coin is considered a circular motion because it moves in a circle of certain radius. So with these few examples, we make a background for further discussion on a few basic concepts related to circular motion. For example, when an object is moving in a circular motion, let's say it moves from a position A to a position B along this path. The path it covers along the circular motion, along the circle, is the length of the arc, and we usually denote it by S. During this motion, the radius has remained constant, but obviously the radius OA goes to the position OB, and there is an angle that is swept by this radius in this manner. When an object moves along this direction from A to B, an angle is swept by this line OA. So ultimately the position A becomes position B. There is a simple relationship between the radius, the arc length, and the angle swept, and that is S is equal R theta. This is a basic relationship that tells us how is the length of the arc, the radius of the circle, and the angle swept by the radius are related. This helps us understand the dependence of this angle on S and theta, and we are in a position to define theta in terms of these two quantities S and R. If S is exactly equal to R for a certain position from A to B, theta is said to be exactly 1 radian. So radian is defined as the angle subtended, and you should remember this word subtended, the angle subtended at the center of a circle by an arc if its radius is equal in length, the angle subtended at the center of a circle by an arc, if its radius is equal in length to the arc, is 1 radian. So if you are asked to define radian, you define that this is the angle subtended at the center of a circle when the lengths of this arc length is equal to the radius of that circle. So this is how we define radian. So that means there are 2 pi radians in complete circle. 2 pi radians. That means that means 360 degree is equal to 2 pi radians. So if you need to convert degrees into radians or radians into degrees, you need to know 360 degrees, which means the complete circle is equal to 2 pi number of radians. That means 1 degree is equal to 2 pi over 360 and so on. You can make these conversions easily. Conversely, pi radians equals 180 degrees. So 1 radian is equal to 180 divided by pi, which means 180 over 3.14, which is approximately 57.3 degrees. There is another important thing that we need to understand before we are in a position to solve questions that appear in the exam. And that is the idea of speed along the circular motion. There are 2 different types of speeds defined. We need to know angular speed, and we need to know how it is different from tangential speed. When we are talking about angular speed, we simply means how quickly the angle theta is being swept. So how fast this theta is changing with time is angular speed. And this is always denoted by omega. This is omega. On the other hand, tangential speed means how fast an object is covering the distance s along the circular path. So delta s over delta t means tangential speed. This is tangential speed. I repeat, when we are talking about how fast an angle is swept, how fast the angle is covered, we mean angular speed. And when we mean how fast this distance s is covered, we mean tangential speed. These 2 speeds are obviously not the same thing, but they are related. A relation between v and omega. How are they related? An important equation that you will remember is V is equal to R. Omega is the relationship between two types of speeds. V is equal to R omega. Let's learn how we calculate omega and how we use omega to calculate the tangential speed V. For example, if you are asked to calculate omega for a second hand of a clock. If I need to calculate this, I will use this relationship, 2 pi over t. You will remember this relation as well, because time period is related to angular speed through this equation. If you calculate omega for a certain object, which is second hand in this case, and you know what time it takes to complete the circle, we can calculate omega for it. We know that second hand takes exactly 60 seconds to complete one circle on a clock. So omega must be 2 pi over 60 in this case. By 60 we mean 60 seconds here, because time will be expressed in 60 seconds. T is 60 seconds for a second hand of a clock. Similarly, if we are asked to calculate omega for the earth going around the sun. Another question, calculate omega for the earth. For the earth going round the sun. We all know that in this case, time period is 365 days. That means this is the total time that Earth takes to complete its circle when it moves around the sun. So this is whole year. So when we express this time in seconds, we'll be in a position to calculate omega. So T is 365 into 24 into 60 into 60. So this all reduces to seconds. When we use this time in this equation, 2 pi over T, we calculate omega for the earth going around the sun. So this is all for today. I hope this will be useful background for you people to attempt the question that I have selected for today. You will be given a worksheet with 2 simple questions in the beginning, comprising a few definitions, but the third one will be about calculating the number of revolutions of the plate per minute. For this question, I'll quickly give you a hint here, because there is already an equation. F is equal to, this is about the worksheet, F is equal to 0.72 W. This equation is giving you an idea what is the force required to hold this coin on the disc. And this is the force. We'll talk about these force in detail later on. This is the centripetal force necessary to hold the coin on the rotating disc. But obviously when the speed of the disc goes on increasing, it will go off the disc. So you will just have to calculate the frequency of its rotation, the number of revolutions per minute for which it can stay on it, the maximum number. So this equation is the force, the centripetal force in terms of its weight, and all these things are given. I hope you will be in a position to attempt this question. Thank you.